Assalamualaikum and hi. Today we will present our group assignment, which is amplitude shift keying. Our group consists of 4 members. My name is Muhammad Nur Fikri bin Borhan. Next, Muhammad SYAQIR bin ABDUL HALIM. Next, HASBULLAH bin HAIRUDIN. And lastly, THEVAPRASAN son of SARVANAN. This assignment we prepared for Dr. Nur AZLAN bin Muhammad ARIS. Let's start with introduction. The introduction for this assignment is, first, amplitude shift keying is a type of modulation technique in communication system which act as a digital to analog conversion technique. The purpose of the modulation was to prevent a variety of unexpected events such as eavesdropping, interference with other signal hacking, and a variety of other ways to keep data, information, and files secure in some way, so that modulating the transmitter and receiver is the best option for most electronic device. Second, the amplitude of carrier signal varies respected to amplitude of message signal. And lastly, amplitude shift keying represents the binary data in the form of variations in the amplitude of a signal. So you can see the expected output amplitude shift keying will generate input binary sequence to amplitude shift keying modulated output wave. Next. How amplitude shift keying works. First, any modulated signal has a high frequency carrier. When amplitude shift keying modulated, it will give a zero value for low input, while it gives the carrier output for high input. Second, the amplitude shift keying will generate the output by shifting the carrier signal and modulating signal when the message signal is high. Lastly, the application on this how the amplitude shift keying modulation works is that when the bit message is 0, then it shows the low frequency, which is the original signal, and when bit message is 1, then the high frequency is shown, which was the frequency of carrier frequency. So, you can see the figure given. The carrier signal is a high frequency carrier. For modulating signal, when the input is 1, the modulator signal will produce a high output. When the modulating signal is 0 output, the modulated signal will produce the low output.
So we'll explain about the project methodology. So this section will show the subtopic and important notes in ASK modulator. So the first is the amplitude shift keying modulator. The amplitude shift keying modulator block diagram comprised of the carrier signal generator, the binary sequence from the message signal, and the band limited filter. Following is the block diagram of the ASK modulator. Next, in this form of modulation, the sign carrier takes two amplitude values determined by the binary data signal. Usually, the modulator transmits the carrier when the data bit is 1 or high. It completely removes it when the bit is 0 or low. There are also ASK shape called multi-level, where the amplitude of the modulated signal takes more than two values. This is the example of the ASK modulation. Next is the ASK demodulator or amplitude shifting demodulator. The demodulation were divided into two types, which is coherent or synchronous, and the second is non-coherent or asynchronous. The first type, coherent or synchronous, are more complex as concern the circuit but more effective as again the noise effect. A product demodulator multiplies the ASK signal by the locally regenerated carrier. Then the non-coherent or asynchronous. The envelope of the ASK signal is detected via diode. In both cases, the detector is followed by a low-pass filter, which removes the residual carrier component, and a threshold circuit which squares the data signal.
Thank you, Syakir, for explaining a bit about ASK demodulator. Next, I would like to explain the detail about ASK demodulator. There is two type of ASK demodulator, which is coherent and non-coherent. First, let's go through to coherent ASK demodulator. Carrier signal at the receiver stage and transmitter stage is in the same phase. That is why we call it coherent or synchronous ASK demodulator. So let's go through the coherent block diagram. As we can see, the receiver will receive the ASK modulated waveform from the channel, but the waveform is affected with the noise signal that have high frequency. So during the multiplier stage, the noise signal will be eliminated or minimized by help of the low pass filter. Next, the signal will go through comparator and voltage limiter. As we know, comparator has two analog input terminal and one binary digital output. So, comparator and voltage limiter objective is help to get a smooth or clean digital output. Next, we go to the non-coherent ASK demodulator. Okay, we call it as non-coherent ASK demodulator is because receiver carrier signal and transmitter carrier signal are not in the same phase. Okay. Next, we go through the non-coherent block diagram. As we can see, ASK modulated waveform will go through square law detector. Square law detector makes the output voltage proportional to the square of the amplitude modulated input voltage. So it's basically reconstruct the original binary signal. Next, same as ASK coherent ASK demodulator, the signal will go through the low pass filter to help minimize the high frequency. Lastly, the comparator and voltage limiter help to get a clean digital output. So basically, the difference between coherent and non-coherent ASK demodulator is whether the carrier signal at the receiver phase and transmitter phase is same or not. And second is coherent ASK demodulator are using multiplier, and non-coherent ASK demodulator using square law detector. Next, we go through the application. This is an example of ASK application in real life or industry. We have a low frequency RF application. RF means radio frequency. Next is home automation device, industrial network device, wireless base station, tire pressuring monitoring system, broadcasting of signal, fiber optic technologies. So as we can see, the advantage of ASK modulator is ASK is offer lower power efficiency, but the disadvantage of ASK modulator is it's very susceptible to noise interference due to the fact that noise can affect the amplitude. Next, the result. I will pass to the table.
So hello, I'm Deva. So now I'm going to just explain a bit about the results that we got. So as we can see, there are 5 signals. So the first 3 are the inputs and the last 2 are the outputs. So let's see the ASK signal. So the first one is the modulated signal. So as we can see, whenever the binary bits are at 1, the modulator transmit the carrier, so we can get the signal. And whenever there's no value or the bit is 0, it will completely remove it. So that's for modulated waveform. And now let's see the demodulated signal. So in this particular experiment, this is a non-coherent demodulated signal because as we can see, it's reconstructed the binary database into demodulated signal. So that's all for results. Now let's move on to conclusion. So at the end of this project, we can know how the process of an amplitude shifting key or ASK work. Besides that, we also learn how the modulating signal and carrier signal related to each other to perform an amplitude shifting key waveform. Next, we also can understand the theoretic of this topic and can design the simulation model of this topic. And lastly, we can know the difference between the two types of ASK, which is the coherent and non-coherent. So that's all from us. Thank you.